This is the screencast for section 3.2, example 7, modeling two states populations using logistic regression. So in the last example, we did exponential growth. Now we're going to use logistic. Remember, we said logistic growth is a better representation of population models because their populations have a maximum sustainable population, their limit to growth. An environment cannot support infinitely many people, insects, animals, whatever it may be, plants, whatever it may be. It has a maximum sustainable population, which logistic growth represents, takes into account. Use the data in Table 3.10 and logistic regression to predict the maximum sustainable populations for Florida and Pennsylvania. Graph the logistic models, and interpret their significance. So we'll talk about what that means in a second. So in my calculator, I put the years in L1, and 1900 I made to be year 0, and then 1910, year 10, etc. The Florida population I put in L2, and the Pennsylvania population I put in L3, as you can see from my lists here. So we're going to come up with a logistic growth regression for each of these. So second stat plot, plot 1, I'm going to make the Florida population. So for me, that would be my X values, my years are in L1, and then the Y values, the population for Florida, would be in L2. Then I'm going to go back up to second stat plot and go into plot 2. Plot 2 is going to represent my Pennsylvania population. So I turn that one on. The X values are still in L1. The years are still in L1, but now the Y values for Pennsylvania are in L3. So I'm going to hit zoom 9 and make sure I'm on track so far. So these data points represent my Florida and Pennsylvania populations. As you can see, the Pennsylvania population starts out higher than Florida, but then towards the end there, the Pennsylvania population levels off, whereas Florida keeps increasing quite dramatically. Now I need to create logistic equations for both of those. So I'm going to go stat, calc, and then, let's see, logistic growth or logistic equation regressions. Oh, there it was, B. Went way over that. Okay, logistic. My first one is going to be Florida, so its X values are in L1, its Y values are in L2. Frequency list can stay blank. I want to store that regression equation, or requation apparently, into Y1. So I'm going to hit enter. Drum roll. It's taking forever. It's okay though. Come on. Equation. Yay! Alright. So there is Florida's equation. Got to do the same thing, but now I'm going to go to stat, calc, B, logistic. My X values are still in L1 for Pennsylvania, but now my Y values are in L3. I want to store that into Y2. Here we go again. Oh, well, that was quick actually. All right. So to put these in a formula or a form we understand, this means y equals C is in the numerator, so 28.02 all over, and then the formula 1 plus A. Their A is 81.90. E to the negative B, their B is 0.047x. So this would be Florida. Then Pennsylvania's will be y equals, their C value is 12.58 all over 1 plus, now their A value is 0.94. That's not very big at all, is it? Times e to the opposite of b 0.034 and then x. Whew. All right, so this is our logistic growth equation to represent Florida's data, and this is our logistic growth equation to represent Pennsylvania's data. We need to interpret their significance. Well, first let's look at the graphs. And I think the significant information that we can gather from these two graphs is that although Florida's population started out small, Pennsylvania's population has a smaller limit to growth. So Florida's population will surpass Pennsylvania's quite dramatically, and we can see that. The now try problem number 50 says, using the data table in 3.14, compute a logistic regression model for Arizona's population for T years since 1800, based on your model and the New York population model from exercise 56. Oh, how nice of them. Well, we haven't done exercise 56 yet, so I guess we're making both of those models just like we did in the last problem. Anyway, compare the two models, and then will the population of Arizona ever surpass that of New York? If so, when? Okay, so let's see. I put my years in L1. I left them from the problem before because we're using the exact same years. Then in L4 I put Arizona's population, and L5 I put New York's population. So I'm going to calculate those logistic regressions and plot them, plot the data points as well as the regression model. So I found my two logistic regressions, one for Arizona and one for New York, and I graphed them. Now New York's population is higher than Arizona's throughout the time span that I can see here, from 1900 to 2000. The question asks, will the population of Arizona ever surpass New York? The answer is no, it will not. Arizona's limit to growth is 15.64 million. New York's is up at 20 million. So Arizona is going to level off pretty much, well, below where New York is right now. So Arizona's population will never surpass New York.